Welcome to the video. Today we are going to solve another Math Olympiad problem, which is on triangles, similarity of triangles, and geometry, right? So the information given is here, but I've also labeled it in the triangle itself. So it is given that AB is 26 centimeter, AC is 33 centimeter, AD is 7 centimeter, AF is 6 centimeter. So I've calculated BD and CF. Then we are given that the parallelogram, which is formed by AD, EF. So AD and EF are parallel, DE and AF are parallel. So this parallelogram's area is 14 centimeter square. And the question asked is, we have to find the area of whole triangle ABC. Okay, so let's get into the video and solve this problem. We start with our plasma method, the first part which is P, problem understanding. So we are given all this information and we have put up a clean diagram with labeling all the different sides which are known. So there is a lot of similar triangles that you can see. BD, this point, let's say I call it G and then call it H. So BDH is a similar triangle to BAC. Similarly, CFG is a similar triangle to CAB. Right? So we can apply some similar triangle concepts here. So let's write down the concept. Okay, so then we have to link the concepts as I just mentioned, that we are looking at similar triangles concept here. In terms of assumptions, so far there is no specific assumptions that we need to make, yeah, so far no assumptions that we need to make. And then let's go ahead and get on and solving this problem. So first of all, let's think about how do we calculate the area of the triangle ABC. Okay, so generally a triangle's area is given as half base into height. So we can take half base into this height, but this base is not known, this height is not known. But one of these sides, half base into height, is known, right? So we can either we have this versus this, and then either we have this or this. This is as a base, and then we can have a perpendicular drawn as a height. There is another formula that is also there, which makes use of this angle in between, because when there are two sides known, you can know the angle in between them, and you can also find out the area of the triangle. So for example, let's say if let's say this R and this S is known, right? So generally, if you think about it, this is the perpendicular drawn from the opposite end to here. So if this theta is known, this angle is known, the height of this will become R sine theta, correct? So the triangle's area will become half into base, which is S, into height, which is R sine theta. So if we are given, if we know the S, if we know the R, then we are, just by knowing the theta, we are able to calculate the area of the triangle, correct? So this is one of the concepts to be used in this problem. How do we use this concept? So what we know is the area of the parallelogram here, which is 7 and 6. But there is a, let's say if you have to calculate this angle here, this angle, let's call it theta. Is there a way to calculate this angle or know this angle? So what will be the area of the triangle from the two side lengths that are given, the 7, 6 side lengths which are given? So as you know that, a parallelogram, if let's say this is again R and this is S, or this is S, then this is S, this is R. So if we put a diagonal here, diagonal through, then the diagonal splits the parallelogram into two equal triangles. So the area here is the same as the area here, right? So both areas are same. So that means that the area of this triangle, if we know the area of one triangle, we can just multiply it to calculate the area of the parallelogram. So in this case, that is actually a diagonal from D to F. Okay. So the area of this will become half into 7 into 6 into the sine of theta. So this is the area of ADF. When we multiply it by 2, we get the area of ADEF. This will become area of ADEF. And this is equal to 14 centimeter square, which is given to us. So when you cancel the 2, so it comes out to be sine theta is equal to 14 divided by 7 into 6. So this is 2, and then this 2 is 1 and 3. So this is 1 over 3. So what we know is our theta is sine inverse of 1 over 3, right? But let's just keep sine theta is equal to 1 over 3. So this is the most important we needed for calculating the area of the bigger triangle, because we already know the side lengths 26 and 33. So area of triangle ABC will become half times 26 times 33 times 1 over 3, which is the sine theta. We are putting this sine theta from here. So this will become 13 and this will become 11. So 13 into 11, 13 is 10, 130, 143. So that is the area of triangle as well as our answer. Okay. So we can, why we chose this way is because we were given the side lengths here. So sometimes these concepts are very useful. If you are given side lengths, you try to obtain this theta. If you are given all the side lengths, then there is another formula of getting the area of a triangle, right? So we have to memorize all those formulas by heart. We could have also calculated this and this based on similar triangle principles, right? We could have gone 27 over 33 is the same as EH over EH plus 6. So we will know EH from there. Similarly, we could have gotten 19 over 26 is the same as GE over GF. Or we could have gone AC over AB is the same as FC over FG. So this is also basically the ratio of two sides on a similar triangle will be similar. So many ways to get this, but we have to always make sure that what is our objective and what is the easiest way to reach there is to calculate this angle is the fastest way for this problem. And we have got this answer. Hope you like this video.